Hey everyone! Today you're getting a behind-the-scenes look at how the technology behind the Nail Pro 1 and the Nail Pro 1 Maxx is created. And this video is proudly sponsored by JLCPCB, high-quality PCB manufacturing. In this first section, we'll focus on the control board. The entire system is built around the 8MEGA328PAU architecture. Here you can see the components organized in the schematic, along with their electrical interfaces and signal paths. Next comes the PCB design stage. This is where we define the optimal routing strategy, ground plane distribution, and all the design rules required to ensure signal integrity, thermal stability, and overall system reliability. In the 3D viewer, you can clearly see the final layout, symmetrical, clean, and structurally balanced. I've previewed it in red, which will be the final production color of this PCB. To ensure the proper operation of the entire system, a reliable power supply is essential. For that purpose, I designed a flyback-type switching power supply using the 5L0380R controller. It accepts an input range of 100 to 240 volts AC and provides a regulated DC output adjustable from 16 to 35 volts at up to 2 amps. In the PCB design, I chose to apply the ground plane only on the secondary side and added stitching vias in strategic locations to improve ground distribution and reduce noise. I also isolated the primary and secondary sections on the board, creating intentional clearance areas to maintain proper safety spacing and reduce interference. Here, in the 3D view, you can see the board without components installed, which makes it easier to analyze the structure. Notice how the ground stitching reinforces the return path. On the bottom side of the PCB, you'll see that the solder island for the rectifier diodes is left fully exposed. This is intentional to increase solder mass during assembly and improve mechanical and thermal robustness. Here you can see a view of the board with all components in place, giving us a clear sense of spacing and overall layout. This visual reference is crucial for evaluating the mechanical structure and ensuring the power supply's stability, which is essential for the proper operation of the entire system. Now we reach an important part of the project. Since we have two models, the Nail Pro 1 and the Nail Pro 1 Maxx, and each one operates at a different supply voltage, I designed a dedicated step-down module. Both models use a 12-volt fan and a 12-volt power button LED, while the main system operates at 17 volts in one version and 32 volts in the other. To handle this, the step-down converter was designed based on the LM2596. Unified design. Because space optimization is a critical requirement in this project, several key functions were consolidated into a single board, which we refer to as the secondary power module. This module receives the primary supply voltage and redistributes it with precision to every stage of the system: power, protection, and logic. It serves as the central hub that ensures each subsystem operates within its intended electrical parameters. In the 3D visualization, you'll notice that part of the layout resembles commercially available step-down modules. However, in this design, the entire voltage distribution architecture is clearly exposed and purpose-built to support the overall system. Now let's move on to the control stage responsible for driving the micromotor. For this purpose, I developed an H-bridge board based on the L298N, but with a key difference. Since the L298N contains two internal H-bridges, both channels were connected in parallel in this design, inputs and outputs, to increase current capability and improve stability. Dedicated design. For this module, I kept the standard commercial footprint, but with connection terminals specifically adapted for the Nail Pro series. The removable jumper was intentionally preserved. One model operates at 17 volts, where the jumper remains in place, while the other model operates at 32 volts, requiring the jumper to be removed. In this configuration, the 5-volt supply is provided by the previously shown secondary power module. In the 3D visualization, you can see that the connectors are positioned to simplify assembly and to facilitate future maintenance or replacement. This layout helps reduce assembly time and streamlines any servicing that may be required down the line. For the rotary encoder, I decided to create a dedicated board, since there are many versions on the market with anywhere from 2 to 4 steps per detent. To ensure consistency, this board was designed specifically to work only with the 2-step per detent models. Rotary design. There's nothing particularly complex about this design. The main focus here is simply maintaining connectors that are fully dedicated to KJ technology products. In the 3D visualization, you'll notice there's nothing especially critical about this circuit. The goal is purely to provide a standardized and dedicated interface. Lighting. And finally, here is the 3D view of this small LED board. Because it's a very simple circuit, it doesn't require detailed technical explanation. Its design allows it to fit between the encoder and its knob, providing illumination for the adjustment button. With all board designs finalized, the next step was generating the Gerber files and moving into full production. For this stage, I went directly to JLCPCB.com, our trusted partner for high-quality PCB manufacturing. Once the files were uploaded, you can clearly see that I selected the red finish for every board, with the exception of the lighting module. JLCPCB's interface provides an excellent real-time preview, allowing you to visualize exactly how the final PCB will look, including solder mask, silkscreen, and overall layout. I then placed an order for 10 units of each design, taking advantage of their promotional manufacturing price of just $5, an incredible value for professional-grade production. With all the files confirmed and the order submitted, the process is now in JLCPCB's hands. Production has begun, and the only step left is to wait for the boards to be manufactured and delivered.
A few moments later.
After 17 days between manufacturing, shipping, and a bit of the usual customs delay here in Brazil, the package finally arrived, and to my surprise, not just one, but 2 boxes from JLCPCB. When you open a shipment from JLCPCB, the first thing that hits you is the level of quality. Every board comes flawlessly finished, with a precision and consistency that honestly puts many high-end manufacturers to shame. The solder mask is clean, the edges are sharp, the silkscreen is crisp, and the overall workmanship feels like something straight out of a professional assembly line. Because it is. These aren't just PCBs. They're the foundation of everything we build. And when the boards arrive with this level of refinement, it elevates the entire project. You can see the attention to detail in every layer, copper alignment, via finishing, plating, planarity, nothing here a feito as presses. It's engineering-grade quality delivered right to your door. And that's why our partnership with JLCPCB keeps getting stronger. They deliver reliability, speed, and a finish that truly reflects the standard we want for our products. Working with them isn't just convenient, it's strategic. Because when your project depends on excellence, you choose a manufacturer that treats your design with the same respect you do. I also took the opportunity to order the stencil for the main board. Since this PCB contains a large number of small SMD components, the solder application needs to be extremely precise, and using a stencil is essential to ensure accurate paste deposition. To make the process even more reliable, I designed and 3D printed a custom fixture that aligns the control board perfectly with the stencil. This guarantees proper positioning during the solder paste application and helps achieve a clean, professional quality assembly. Don't miss the next video, there's a lot more coming. After installing the components on the power supply, the result is extremely satisfying. The printing process for the Nail Pró 1 Maxx enclosure is almost finished, and as you can see, there are still quite a few strings. Thank you for watching.